Good afternoon. I am Dilip Kumar Reddy, Assistant Professor of CSC Department from G. Pullard Engineering College. So today we are going to be discuss some basic introduction concepts related to data communication and networking. So just to mention what are the topics we are going to be cover. So we are going to be check what is in data and what is in communication. And coming to the next topic here, we are going to be see about what are the components need for the data communication, and same as we check what is in syntax and we check what is in protocols here. And after the completion of all these concepts, we go for the two different types of network models. Two different types of network models. So coming to the first basic introduction here. So before going to be talk about the data communications, what is the meaning of a data here? So simple thing, data refers that a piece of information. The piece of information may be present in any form. It's like an text, or it may be an audios or videos or images or anything. So that type of data, that type of context we referred as in data here. And what about the communication? So the communication refers that exchange of data between two devices. So what the mean of devices here? Coming to the networks, I mentioned the devices are nothing but host or client or server or nodes or anything that comes under the devices. So the communication is nothing but exchange of data between two devices via a transmission medium. Transmission medium is nothing but a cable. So these cable acting as a medium between two devices. So that we name it as a communication. And just put together here, what is the meaning of a data communication? The data communication, we are communicating the data between the two devices, that we name it as a data communication here. The simple thing here, we are making some communication, transferring the data between the two devices. So the two devices are nothing but host or client or server or two nodes via the transmission medium. So the transmission medium acting as in cables here. So coming to these different types of cables, just I'm pointing out what are the transmission mediums available for us as of right now. So the first basic thing is an optical fiber. And a twisted pair. Optical fiber twisted pair. Just I will show you the images, what represents here. Yeah. Yeah, coming to these different types of images we are having, we are using all these cables as a transmission medium in our basic usage. So the first one is acting as an twisted pair cable. Sorry, this one acting as an optical fiber cable. And this is also one type of cable which comes under the usage of communication only. This also comes under the optical fiber. We generally name it as an LAN cable or CAT cable, but it comes under the category of optical fiber only. And this is a wireless transmission. And there is one more thing, there is a twisted pair also. This is an old version of cable we use for the transmission in the olden days. So just as of right now, we are not using this twisted pair cable because this twisted pair transfers at very low rate compared to the optical fiber compared to the optical fiber, because this twisted pair cable is made up of some copper wires. When you use this cable for the long time, automatically the copper wires will be turned into warmer, or turned into the warmer. So automatically it stops the transmission. It stops or it slows down the transmission. So that's why we're not using this type of twisted pair cables in this moment. So we are using the optical fibers. These complete optical fibers are made with an optical fiber which transfers the data at very high rate compared to the previous types of cables. So these are the different types of cables we use for the transmission. And coming to the previous things here, we have seen the data communication, the basic definition. Data communication or the exchange of data between the two devices via some form of transmission medium such as wire cables. So we have seen the transmission mediums as wire cables. And coming to this one, coming to the components, what type of components we need to establish a communication. So the first one is an sender, and the next one is an receiver, and the next one is a message. We need a message. Without message we not do anything, right? So we need a message. And the next one is a medium, and the next one is a protocol. This protocol is very important here. We need to follow the protocol when we are going to be make some communication here, or when we are going to be establish the communication. So coming to this one, just we talk about all these 5 components which helps to form a data communication system. The first one is a sender. It's one of the device or a person. The person or a device wants to make some communication with another person or a device. First, the sender needs a message. So the sender is a person or a device. It need to be send the message. It should be having the capability to send the message. And same thing, receiver is a device. The receiver is a device. It needs an capability to receive the message. And same thing, message is a piece of information, whatever the thing we want to share. So there is a basic thing here. And medium, we already discussed the mediums. So all this red color indicates the medium here. So this medium is like a twisted pair or optical fiber. All this comes under the medium here. And coming to the protocol, what about the protocol here? This protocol makes a key role here. So the protocol is nothing but a set of rules where we need to follow when we are doing some communication. So the protocol is nothing but a set of rules. So we need to follow these set of rules when we are doing any communication. So what consists inside the protocols here? So let me check. Going to the protocols here. Yeah. See here. Coming to the protocols. Protocol is a set of rules. That govern data communication. That govern nothing but we need to follow the set of rules when you are doing any communication. So what consisting of a set of rules inside these protocols means? One is an syntax, semantic, and one more is an standard. Syntax, semantic. Just I will show you this one. These are all the next concepts. Yeah. Coming to the syntax, coming to the protocols here. So there are three different types of protocols. We need to follow that one. There is a syntax, semantic, and timing. Syntax, semantic, and timing. What defines the syntax and what defines the semantic and what defines the timing? So coming to the syntax here, it's simple thing. When we are going to be do the communication, we need to follow some set of format or some set of format or some structure when we are going to be send the data. So it's like a simple thing. If you are sending any packet, the first field indicates source address, the second field indicates destination address, and the third field indicates our original content. So this is a default rule we need to follow. So if you mislead this rule, suppose if you have been placed the first shell with the destination inside the network, the routers and the switches will be mislead that. So that's why we need to follow the syntax. Syntax nothing but it refers the structure or format of the data. When we are going to be send any data, we need to follow the structure. So this is a basic thing when you're going to be sending data here. And semantic, what defines the semantic here? Semantic is nothing but which interrupts the meaning of the data what we are going to be sent. So whatever the data we are going to be sent, that data should be consisting of some meaningful. So that refers the semantic. And coming for the timing here, what refers the timing here means when that we need to check the two different types here. When the data should be sent and how fast the data can be sent. That means when we are sending the data and how fast we are sending, when we are sending the data and how fast we are sending. Because when we are sending means the destination should be ready to access that, and how fast we are sending means the destination need to be synchronized for our fastness. So that is the timing here. That is the timing. So we need to follow these three different types of rules. It's nothing but protocol. One is in syntax, semantic, and timing. These are very crucial part when we are following the data communication or when we are doing the data communication here. Syntax, semantic, and timing. And we have seen these protocols here, and just I go with the basic here. We have been skip some concepts here. Yeah, we've seen the data communication, and we have seen the components. What are the components needs for the data communication here? What are the components needs for the data communication? You have seen these one, and coming to this one, we have seen these images also. These are the different types of images which we use for the medium, and there are different types of data representations which we use for the communication. Not only the text. Just don't mislead. We're not communicating with only the text. We are communicating with the images, and we are communicating with the audios and videos, and same thing, large type of files also. We are communicating with the large files also. Don't mislead. We're not communicating with only the text. We are communicating with the different types of formats. It's like an images, audios, and videos, and text. Okay. And coming to the data flows, how many types of data flows we are having? Means there are three different types of data flows. One is in simplex, half duplex, and full duplex. Oh, before going to be these data flows, what about all these data flows means? The data is flowing from sender to the receiver. In how many ways we can send the data from sender to the receiver? In how many ways? That is in three different ways. That is in simplex, half duplex, and full duplex. And what about the simplex, and what about the half duplex, and what about the full duplex? So we can use any type of data flow in the communication, but maximum in the real world we use the full duplex data communication. We use the full duplex data communication because it was an very advanced one. So coming to the simplex here, what deal is a simplex? Means in the simplex mode, we transfer only the data from one direction to other. Only from one direction to other, not the data from the two directions. We transfer the data from one direction to other only. That means that, just an example, we are giving the input from keyboard to the monitor. So the monitor doesn't send any information to the keyboard again. It's not and vice versa. We are sending the data from one device to another device only. So just an example for this one, we are sending the data from keyboard to monitor. So and we're not getting the data from monitor to the keyboard again. So this type of transmission, we name it as a simplex. So this happens more at olden days, where we are having some mainframe servers. So there we have seen this type of simplex type of data transmission. And half duplex. What is a half duplex? So in this half duplex mode, we do the communication in two directions, but not at the same time. So see here, if this is an just assume this system is an A and this system is an B. For this second, this is an 10th second. For this second, I want to send the data from A to the B. So the A is sending, B is listening. It's nothing but B is receiving the data here. And for the next moment, the B wants to send the data to the A. B is sending and A is receiving the data. But we not do the same things at the same process. That means that one system is sending and one system is receiving. So we are sending the data. This half duplex is an bidirectional, but it's not happen at the same time. We are using only one direction at a one time. The best example for this one is an walkie-talkies. Have you heard the word walkie-talkies? Just we are using these walkie-talkies in this mode only, half duplex mode only. So we use this type of communication in the networks also for communicating between the devices. So, but not at everywhere. At some places we can use these one, not at everywhere. So this is an off duplex mode. Maximum we won't use this one because we won't get good performance for the network. If I use this simplex and off duplex inside the network, this is my network. Inside the network, when I use the simplex, transmission of data is not happen. And when I use the half duplex, transmission of data will be happen, but it takes so much of time. So these two modes or these two data flows doesn't make any sense in the real time or in the real cases. And the performance of the network will be gradually decreases. So when the performance of the network decreases, automatically no other person will send the data through my network. No any other person or no other any device send the data through these type of networks, because the performance of the network was very low. So because we are going for the full duplex mode. This is a very good data flow. Coming to the full duplex mode, we can communicate at the both directions simultaneously. It's like a telephone. It's like our mobile system or telephone. We are talking and receiving, and we are talking simultaneously, and we are listening simultaneously. So this is a full duplex. This type of data communication will be happens in the most cases of networks, because it increases the performance of the network. If the performance of the network was decreases, automatically no one will use my network for the transmission. That was very fault for me. So these are the three different types of data flows, or we name it as an, or these data flows also named as an modes of transmission. transmission. We name it as a modes of transmission also. Just have write it down here. Modes of transmission. This data flow, we name it as a modes of transmission also. Yes, this is one type of, these are few different types of data flows inside the network we use for communicating with other devices. And coming to these important characteristics of networks, I already said that the performance of the network will be decreases automatically. No other devices can use my network for transmission. So how should I judge that my network was perfect? How should I judge that my network was perfect? There are some characteristics. There are some fundamental characteristics which defines my network was and communication wasn't perfect. So sorry, I'm talking about this communication, data communication. How the effective the data communication is, that means that depends upon the four different types of characteristics. One is an delivery, accuracy, timeliness and jitter. So what is a delivery here? These are the four characteristics: delivery, accuracy, timeliness and jitter. What is a delivery? The system must deliver the data to the correct destination. There is a predefined work in the communication system. The system must deliver the data to the correct destination. In the network, there is three devices, A, B and C. I want to communicate my data between A and B, but the network is delivering the data to the C, means it's not an good communication. My intention is I want to send the data from A to the B, not from A to C, but the network is forwarding the data to the C. So this is a wrong communication. This is unauthorized. If suppose these type of things happens inside the network, that communication was wrong. The system must deliver the data exactly to the destination system. So when the data receives exactly to the destination system, we say that the delivery was perfect inside the network. And what about the accuracy? There is one more characteristic, accuracy. Yes, the system must deliver the data accurately. What it mean accurately? Accurately means data that have been altered at some places in the transmission. So it doesn't happen inside the network. Alteration didn't happen. So accurately or accurate. Sometimes we name it as an accurate also. The system must deliver the data accurately to the destination system. That means the data doesn't undergo for any corruption in the transmission. Any data corruption in the transmission that leads an accuracy in the communication. If suppose I am sending two messages from A to B, the first message was transferred to the B system accurately, and the second message was transferred to the B system, but the second message was corrupted in the transmission. How the accuracy is this one? It's an 100% accuracy? No, it's only the 50% of accuracy. I forwarding the two different types of messages. The first message was gone to the destination system exactly without any errors inside that. But coming to the second message was corrupted in the transmission. So the message was corrupted in the transmission. So I won't give 100% accuracy here. So the system must deliver the data accurately to the destination system. That is our main goal here. And coming to the timeliness mentions that the system must deliver the data in a timely manner. If suppose the system sends the message to the destination system after 1 hour, means it doesn't use. The system must send the data to the destination system within time. That mentions the timeliness, or timeliness is nothing but one of the character which defines the data communication was very effective, or sometimes we can define these type of characteristics for the measuring of performance of the network also. So the timeliness is one of the character here. We need to check the characteristics of the complete data communication. We need to send the data to the destination system in correct manner, in a timely manner. And what about the jitter? This is one type of different concept here. As of right now, just I will go with an basic definition for the jitter. Jitter refers to the variation in the packet arrival time. What it means in the packet arrival time means, coming to the jitter, this one type of error which occur mainly in when you are going to be communicate videos or audio files or video files. These type of error will be occurred for the audio files and video files. Not occur for the text files. So this is one type of problem which we face in the audios and video files when you are forwarding here. So these are the 4 different types of characters which measures the data communication was effective or not. The first one is, and just we repeat, the first one is on delivery, and the next one is on accuracy, and the next one is on timeliness, and the next one is on jitter. Okay, and we've seen these message sender and things. We've seen these images, and we've seen the different types of data representations, and we've seen the data flows. And right now, what is the network? We are going for the somewhat of advanced concept here. What is a network? Simple definition: a network is a set of devices. Where all the devices are communicating with the links. Just I'm drawing a basic diagram for the network. This is on 1, 2, 3, 4, and 5. In the network, I'm having 5 devices. So what the network says, that means a network is a set of devices. These 5 devices are set. So I says that this is an one network. A network is a set of devices where all the devices are communicating with communication links. That means that every device should be communicated with all the devices. All the devices are connected within communication links. A network is a set of devices where all the devices are connected by an communication links. All these links comes under the transmission mediums, like we already discussed: twisted pair, optical fiber, and some coaxial cables also. So that all these 3 different types of cables comes under the links here. So this is a basic definition for the networks. Network is a set of devices where all the links are connected within communication links. So coming to the network, we see different types of formats inside the network. One is an point-to-point, one more is an multi-point. So what is a point-to-point and multi-point means? Network here, there are 2 systems, A and B. A is directly connected to the B. That means that A is communicating to the B with a link. That link was directly connected to the B. So this is a point-to-point. That means that this link is not shared by any other system. any other system or any other node. The link was connected between the two devices. It's a point to point. The link is not using for any other transmission. The link was using for the transmission between A and B only. So there is a point to point. And coming to the multi-point here, coming to the multi-point. So coming to the multi-point here, just observe this image. I'm having one link. One link was sharing with multiple devices. With multiple devices, we can share with another device also. That means that this link was serving its services to all the systems what they are connected. This is a multi-point. So these different types of connections we observe in the network also. There is a point-to-point and multi-point. So point-to-point makes a very effective, but it's a very costly one, and multi-point it's a very cheaper one, but the effectiveness was very low compared to the point-to-point. We will discuss why this point-to-point was a very effective one and why the multi-point was not very effective one in the next coming videos here. Next coming videos or next coming topics. So just we'll go for the next topic, that is in topology. There was a very important concept here. Topology. What's in topology? One of the most important concepts inside the network. What's in topology? Topology defines the structure of network, how all the components are interconnected to each other. Topology defines the structure of the network, how all the components nothing but system, nodes or devices or anything which are inside the network. Topology defines the structure of network, how the components are interconnected with each other. Interconnected means how the components are connecting with each other. So this defines the topology and simply says that topology refers the physical structure of the network. It's not a textbook definition. It's my own thing. Topology refers that physical structure of a network. Physical structure of network. How the network seems to be. That defines the topology. Coming to the topology, there are different types of topologies here. There is a mesh topology, star topology, bus topology, and ring topology. Mesh, star, bus, and ring. These topologies are very important, and every topology having different types of structures, different types of structures here. So just we go for the mesh topology. Just observe the structure of the mesh topology. There are 5 systems. And every system is connected with all the other systems. That means that every system is connecting with n-1 devices or n-1 systems. There are 5 systems means we need to connect with the 4 system. The first is this one, first, second, third, and fourth and fifth. The first system is connected to the second system, and same thing, the first system is connected to the third system and fourth system and fifth system also. This is nothing but n-1 connections. It's like a mesh. Or web form. It's like a web. It's like a spider web is right. Spider web. Like that, we are making the network also. We are making the connections inside the network. Okay. This is a mesh topology. And coming to the star topology. Here the star topology defines that it's like a star. All the devices are connected to one point. There is an hub or controller. We name it as an hub or controller. All the systems are connected to this hub or controller. That makes a star topology here. And one more topology is there. There is a bus topology. Bus topology. There is a long cable. All the systems are connected to that cable. It seems to be a multi-point, but it is in bus topology. It's in bus topology. So basically, we use these bus topology to establish our laboratories. We establish this bus topology. We use this bus topology to establish our laboratories in our college. And there is a ring topology. Just observe the structure. It's like a ring form. So that's why we are naming it as a ring topology. And there is one more, is a hybrid topology. Hybrid is nothing but combination of any two topologies. Combination of any two topologies. We say that it's an hybrid. Just observe what are the different types of topologies here. Hub means star topology, and same there is an bus type of structure. This is an bus topology. Bus topology. So these are the different types of topologies which we use in the networks. These are very important. There is a mesh topology, star topology, mesh topology, star topology, bus topology, and ring topology, and hybrid topology. So these are very important inside the network here. Okay, and let me see different concepts in the next coming class. Okay, thank you.